Hello students, welcome to class of science. Students, in the previous lectures we were discussing about the unique properties of the carbon. So students, in the continuity of that lectures, today also we are going to discuss one another unique property of the carbon, that is allotropy. That is allotropy. What is allotropy? Allotropy is the existence of the element in more than one form. Existence of element in more than one form, which have more than one form, which will have same chemical properties and different physical properties and different physical properties. Now students, these forms are known as the allotropes. These are known as the allotropes. When an element exists in more than one form, which will be having similar chemical properties but different physical properties, this property is known as the allotropy, and these forms are known as the allotropes. Now carbon has also many allotropes, students. It has also the property of the allotropy. Carbon has two types of allotropes. One are known as the crystalline allotropes and other are the amorphous. Now students, what is the difference between the crystalline and amorphous allotropes? Crystalline allotropes have some geometrical shape. They have regular geometrical shape, but the amorphous allotropes don't have geometrical shape. They exist in powdery form. Like the example is coal, charcoal. They don't have any geometrical shape. So they are known as the amorphous allotropes of the carbon. Now students, in this lecture we will discuss the crystalline allotropes of the carbon. There are three crystalline allotropes of the carbon. One is diamond and other is graphite, and third one is fullerenes. Now students, as we have defined earlier that the allotropes of the carbon have similar chemical properties. Now students, why chemical properties are similar? Because chemical properties depend upon the constitution of the element, because these three forms all are made up of carbon, and on burning each of them will produce carbon dioxide gas. So their chemical properties are similar. And now what is the reason why physical properties are different? Because students, physical properties depend upon the structure of three forms. How the carbon atoms are arranged in these forms. How carbon atoms are bonded together, in which manner they are bonded together. It makes the difference in the physical properties, because it is different in all the three forms. Now we will start from the diamond. In the diamond, carbon is attached to other four carbon atoms in a three-dimensional rigid structure. What they are making? Three-dimensional rigid structure. You can see in the structure, students, it is just a model. The carbon is attached to four other carbon atoms. Right students, forming a three-dimensional rigid structure. That is the reason that diamond is the hardest substance. It is the hardest substance ever known. Other thing is that when I am saying that it is forming, carbon is forming another bond with other four carbon atoms, so its outermost shell is complete. So no electron is left free. So diamond is a bad conductor of electricity. So it is a bad conductor of electricity. It is hard and it is a bad conductor of electricity, and it forms three-dimensional rigid structure. Now comes to the graphite. In graphite, the carbon atom is attached to other 3 carbon atoms in a hexagonal position, in a hexagonal shape. Right students, see it is a hexagonal shape and each carbonate attached to other 3 carbon atoms, and these are found in the forms of the layers. Like these layers are very flexible. They can shift from here to there. So this is the reason the graphite is very soft and slippery. Soft and slippery. First they form a hexagonal structure. Now students, as I have told you, in the graphite, each carbonate is attached to other 3 carbon atoms. So one electron is free to move. So it is a good conductor of electricity. Graphite is a good conductor of electricity. That's why it is used as electrodes. It is always used as an electrode. So graphite is a good conductor of electricity. Now third allotrope comes the fullerenes. Fullerenes, why its name is fullerenes? Because an architect whose name was Buckminster Fuller, he made a dome which was similar to the shape of the fullerenes. So we gave it a name fullerenes. Fullerenes is basically a C60 atom which contain how many carbons? 60 carbon atoms. Fullerene contains 60 carbon atoms. Most of the properties are yet to be studied about the fullerenes, but it has a structure of football which contains hexagons of carbon atoms and also pentagons, and there are 20 hexagons and 12 pentagons in this structure, which is similar to the football. Right student? So these are the 3 allotropes of the carbon which have similar chemical properties, and these have different physical properties, because in these allotropes, in these forms, the arrangement of the carbon atoms, how they are bonded together is different. So the physical properties are different, and their composition and their reaction and the product is same after the chemical reaction. So their chemical properties are same. These are the 3 crystalline allotropes of the carbon. The next topic we will discuss in the next lecture. Till then, take care. Have a nice day. Thank you.